Hey everybody, welcome back. Today's lesson is 4.7. We're going to be discussing real numbers. Real numbers today. You may be thinking, real numbers? Haven't I been discussing real numbers the entire time? Yes, you have. Yes, you have. We've been talking about real numbers the entire time. But now we are going to be discussing how to classify them. So we're going to be classifying them as different numbers. All right? So let's go. A couple of vocab words today. All right, so the very first thing is when you remember from science. In science, they have different classifications based on shared characteristics. Okay. For instance, here is the classification of a horned lizard. It would be an animal, which is right here. Animal. Okay, then it's a reptile. It's also a lizard and a gecko. Okay, so if I look at this, it would be animal, reptile, lizard, gecko. It would have different classifications. However, we know that it is going to be a horned lizard. Well, math has those same types of things. Okay, it has different classifications, and we're going to be talking about that today. All right, so if you remember rational numbers, remember, rational numbers can be written as a fraction. So we've talked about rational numbers before when we started dealing with equations. Now we're going to get into irrational numbers. Just remember, rational numbers can be written as decimals that terminate or repeat, and it's any number that can be written as a fraction. All right? So there are also numbers called irrational numbers. And what are those? Well, write these down and see. So pause now, write these numbers down, or write these words down, and I will explain afterwards. All right, so if you look at irrational numbers can only be written as decimals that do not terminate or do not repeat. That means they keep going on and on and on and on forever, yet never repeat. Okay, there's, if you look at the very bottom one, the square root of 2, that's an easy one. Square root of 2 is an irrational number. All right, so if you look at irrational numbers, we know rational numbers can be written into fractions, while an irrational number can't. Okay, it cannot be made into a fraction, as you see here. All right. However, a quick, easy way to see if it is an irrational number is if a whole number is not a perfect square, then its square root is an irrational number. Again, going back to the square root of 2, notice this 2 is not a perfect square. Okay, remember your perfect squares would be 1, 4, 9, 16, so on and so forth. It is not a perfect square. So if it is not a perfect square, it is an irrational number. A little hint for that. There you go. Okay. All right. So please pause this down. Pause and write this down now. All right. So real numbers, the set of rational numbers and the set of irrational numbers. Okay. Basically, when you look at real numbers, okay, there's classifications. Now I'm going to start down here at whole numbers. Whole numbers are any numbers that you could count on your hand. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to positive infinity. Okay? Notice they do not include negative numbers. Whole numbers are not negative. They're all of the positive numbers. All of those positive numbers that you could count on your hands. So again, 1, 2, 3, 4, 5, 6, 7, so on and so forth, 257, 92, yada, yada, yada. Now, integers. Integers, if you look at all of those whole numbers and then add all of the negative numbers, all of the negative whole numbers, those are integers. All of your positive and negative whole numbers. So I gave you a couple of examples of -2, 97, 14, -2, 53. If it is a positive or negative whole number, it is an integer. Now, the other thing that you can look at this, all right, all whole numbers are integers. However, not all integers are whole numbers. Okay? All whole numbers are integers, but not all integers are whole numbers. Example, -2 is an integer, but it is not a whole number because it is negative. Okay? Then, we also have rational numbers. Just talked about that. Any number that can be written as a terminating decimal, repeating decimal, and as a fraction. Okay? So, written as a fraction. So, 11/17, 1/3, 2.5. All of these are, again, all of these are rational numbers. And to go with our flow, all integers are rational numbers. All integers are rational numbers. However, not all rational numbers are integers. We don't go down. We don't go down the ladder. We always go up. All whole numbers are integers and all integers are rational numbers. Then, but not all rational numbers are integers, because if I give you the number, let's say -2.7, is 2.7 a positive or negative whole number? No, it's not. Okay? Then, all rational numbers are real numbers. Okay, so on that left side, notice how there's that big dividing sign right here? Divider. Okay? Rational numbers are not irrational numbers. All right? It's either going to be a rational number or an irrational number, not both. Cannot be both. All rational numbers are real numbers. Again, but not all real numbers are rational numbers. Not all rational numbers are integers. Not all integers are whole numbers. Okay? Then we get into irrational numbers. Irrational numbers, things like pi, maybe you've talked about pi before, but the square root of 15, square root of 2, any non-perfect square is an irrational number. So again, square root of, let's say, 17, square root of 129. All of these are irrational numbers. And all irrational numbers are real numbers. All irrational numbers are all real numbers, but not all real numbers are irrational numbers. Again, we can go up, but we can't go down. All right? Now, you may be wondering, well, Mr. Siemens, if we're talking about real numbers, are there imaginary numbers? Yeah, there are. There are imaginary numbers. If I told you to find the square root of -49, can you do that? No, you can't, because you can't find the square root of a negative number. Okay, that would be an imaginary number. The answer would actually be 7i. I explaining that it is an imaginary number. Okay? Okay. Awesome. Now, I didn't mention you do not need to know imaginary numbers. Don't worry about that. Know real numbers and the set of all real numbers. So rational numbers, integers, whole numbers, and irrational numbers. Now, it says, write all names that apply to each number. So if you look at that, the square root of 5 and -12.75 and the square root of 16/2, come up with what classifications are these numbers. Now, if we look at this last one, you need to simplify before you figure it out. So simplify that last one before you figure it out, and then classify it. So classify all of these based on the information that we just talked about in that last slide. Use that last slide to your advantage. All right, so pause now, write all of these down, including directions, and then try to classify them. Go! All right, let's see how you did. Square root of 5. The very first thing that's going through my head is 5. Square root of 5. Is that going to be, what do we know about the square root of 5? Is that a perfect square? No, it is not a perfect square. Well, if I'm trying to find a square root of a non-perfect square, what type of classification is that? Irrational. That is an irrational number. What do we know about all irrational numbers? They're also real numbers. Real numbers. Okay? So irrational and real. They both need to be written down for that one because we're looking at all names. -12.75. Okay? Negative 12.75, that's a decimal. What do we know about decimals? Well, decimals that terminating decimal, is a rational number. What do we know about all rational numbers? They are also real numbers. So, the first one was irrational real, second one was rational real. Now we have to find the square root of 16 divided by 2. Well, we need to simplify first. Square root of 16 is what? 4. Divided by 2. What's 4 divided by 2? 2. So, what classification would be 2? Well, it's a number we can count on our hands, right? So, it is a whole number. All whole numbers are also integers. Don't forget about that. But all integers are also rational numbers. And all rational numbers are real numbers. Okay? Whole, integer, rational, real, whole, integer, rational, real, whole. Awesome. Okay? Next slide, you're going to keep the same directions and just write the new problems down. Try to get these. You might need to simplify a little bit. So try this one. All right? Square root of 9. What's the square root of 9? 3. So what is 3 as far as classifications? Well, again, a number I can count on my finger. So it is a whole number. What do we know about whole numbers? They are integers. Integers. What do we know about integers? They are rational numbers. What do we know about rational numbers? They're also real. Rational numbers are real. Next, we have negative 35.9. Can we count it on our fingers? No. Is it a whole number? Sorry, is it a positive or negative whole number? No. Is it a decimal or fraction that terminates or repeats? Yep, it is a decimal that terminates. So we know that is a rational number. I just went through all the scenarios in my head. We also know all rational numbers are real. Real numbers. Real numbers. All right? Last one, we got to simplify again. Okay? Square root of 81 is what? 9. Divide that by 3. It is 3. Hey, guess what? We just did that one right up here. Oh my goodness, Mr. Sheeman. We just did that one. So I have all my answers. My answers are whole. All whole numbers are integers. All integers are rational. All rational numbers are real numbers. All right? Done. We are done with this slide. Not today. I hope you weren't thinking we were done for the day. Let's go. Okay, state if each number is a rational number, an irrational number, or not a real number. If you look at this, again, is it a rational number, irrational number, or not a real number? You are not. You're not classifying them fully. Just telling me, are they rational or irrational or not a real number? So pause now, try these two. All right, square root of 21. Does anybody know if 21 is a perfect square? It is not. It is not. So my answer, irrational. We know that square root of 21 is a real number because it's a number we can come up with. If you type that into your calculator, you can come up with your number. Okay, then we'd have 0 divided by 3. 0 divided by any number is what? 0. Okay? Can you describe that as a fraction? Yeah, I just did. 0 over 3. So this is going to be a rational number. Again, you may be thinking, well, it's a whole number, Mr. Sheeman. It's a whole number. Look at the directions. This is the directions. It asks, is it a rational, irrational, or real, or not a real number? Okay, so make sure, look at those directions, and your answer would be rational. You've already written these directions down, so all you have to do is come up with your answers for these two problems. Check that second one. You might need to simplify. So pause, write it. Okay, If you look at the square root of -4, square root of -4, can we come up with our answer? No. Why not? It is not a real number. Remember, we cannot come up with a square of a negative number. It's not a real number. Next one. What is the square root of 4/9? Well, we need to take the square root of 4 over the square root of 9, which is 2 over 3. Is that a rational number? It can be described as a fraction. It is a rational number. Rational. Okay, the density property, okay, between any two real numbers is another real number. It is also true for rational numbers, but not for whole numbers or integers. Okay, for instance, if you look at -2 and -3, there's not an integer between -2 and -3. We know there are numbers in between, but they are not integers. Okay, they're not integers. So we're going to be finding numbers in between or a number in between two numbers. Okay? All right. So let's try it. So that's the density property. In between any two numbers is an infinite number of numbers. Okay? So if I say find a real number between 3 and 2/5 and 3 and 3/5. You may be wondering, Mr. Sheeman, they're right next to each other. How is there a number in between? Okay, I always like to come up with the next denominator up. For instance, I like to multiply each of these fractions by 2. Okay, I would have 3 and 4/10. I'd also have 3 and 6/10. Is there a number between 3 and 4/10 and and 3 and 6/10? Yeah, there are. It is 3 and 5/10. Right in between the two of them. Okay? It would be right in between 3 and 4/10 and 3 and 6/10. Okay, so come up with maybe a new denominator and come up with a number in between their numerators. All right? Try this one on your own. Last slide of the day. So pause, try it. All right, it says 4 and 3/7. It also has 4 and 4/7. I'm going to get a common denominator. Common denominator of 14, which is 6/14 and 4 and 8/14. Is there a number between 4 and 6/14 and 4 and 8/14? Yeah, it's 4 and 7/14. Right in the middle of them. Whoop, whoop. All right, that's all I have for you today. I hope you have a wonderful day. See you later. Bye.